Hey everyone, thanks for having me, and thanks for coming inside despite the nice weather outside. So we'll talk about how to bootstrap an autonomous AI agent economy. And no worry, there's a lot of words there, we'll uncover it. So first, I present you this very scientific study about economic growth. So I went ahead and asked ChatGPT about economic growth. And here above, we have the growth so far at around 100 trillion US dollars world economy. And with the arrival of autonomous AI agents, we're looking at up to quadrupling that in 25 years. So here we go. Obviously, that's a joke, but that is actually a real response from the model. The point why I'm showing this isn't to argue whether this is a correct prediction. It doesn't really matter. But what's important is for you to start thinking about what would it mean if autonomous AI agents arrive at the scene at large and basically contribute to our economies. What if all of us have one or more autonomous AI agents that do things on our behalf? Because what does autonomous AI agent mean? It's basically a software system which does things on behalf of its owner, which can be you, right? So let's look into this and find out. So who am I? I'm co-founder and CEO of Valerie. That's a labs. We built open source technology. I'm also a co-founder of the OLS protocol. And back in the day, did a PhD in economics on applied game theory. The mission we have at Valerie is to basically enable groups of people and individuals to co-own AI systems, and today we're focused on autonomous agents. For this presentation, I want to cover a couple of things. So I want to familiarize yourself with OLS. Then I want to go into this topic of what do I mean by an AI agent economy. It'll be a very high-level description, and then I'll go into a use case example which outlines an AI agent economy which we can see today and where all of you can actually participate in. And then the important point, the actual title of the talk, I'll then equip you with the knowledge to basically go away and bring an autonomous AI agent economy to your protocol or your chain or more generally your use case, which could involve some crypto or not. Finally, we'll cover some of the aspirations we at Valerie have for these kind of economies. And then we'll have time for questions. So everything I'm talking about here is not some sort of theoretical construct. It's based on actual iteration, actually working on this problem day in and day out. The OLS ecosystem has generated more than 700,000 transactions across various blockchains. The primary one in terms of transaction counts is actually Gnosis chain. And we think we've therefore demonstrated that autonomous AI agents can be daily active users of protocols and chains and are actually growing that every day. The last time I gave this presentation in Denver, this 18% were 10%, now we're at 18%. So basically OLS agents have now made a significant number of lifetime transactions of the SAFE protocol. The reason why SAFE, small aside, is because we use account abstraction for those who know what that is. But generally speaking, the message is AI agents aren't just coming, they're already here, and the question is now how fast are they going to grow? So OLS, the protocol, and the stack are ultimately, in a nutshell, there to generate more autonomous agents and more autonomous agent economies, right? So what I mean by this exactly we'll cover in a second, but that's one way to think about OLS. Now, on a technical level, what we enable is you as a developer or you as an operator, i.e. a person running an agent, to basically have these agents in different configurations. You can have an agent which runs on your local device or your cloud instance or your decentralized network, which does things on your behalf. We call that a sovereign agent. You can have the same kind of software deployed as a multi-node system. Think blockchain, but it's a different thing, where basically it forms a decentralized autonomous agent. If you want to go into the technical specificities of this, come to our stand, because it's quite involved. But ultimately, this allows a group, for instance, members of a DAO, to own one autonomous agent that actually, on a physical level, is a bunch of nodes collectively implementing this. And then where it becomes very exciting, and this is in a way no news, but we're leveraging it heavily in OLAS, is once you have multiple agents interacting, you have multi-agent systems. In multi-agent system, the key thing is that rather than what you care about coming from one specific agent, the thing which you care about comes from the interactions of agents. All of us in this room are actually members of multiple multi-agent systems, right? If you go to work, you're not there to do your specific thing. Your specific thing in isolation would be quite meaningless. It's the organization as a whole you're contributing to, which is a multi-agent system, and the emergent outcome is whatever your organization is shipping, actually. So really, what I'm talking about is just taking that concept which we have with humans and then moving it into the realm of software and thinking about how can we scale these systems and direct their attention exactly where we want them to. So final point on OLAS, I think, is that there's many different ways for you to get involved into OLAS right now. Depending on your skill level and what you're actually interested in, there's ways to contribute without any code if, for instance, you want to grow awareness about OLAS, or you can contribute in a more kind of DeFi way as a bonder. You can operate agents, you can build agents, you can launch entire use cases, and you can govern the protocol. Again, come talk to us, we can guide you in the right way, or you can just go to olas.network and to the Get Involved section. So let's get to the meat of it, and first describe at a very sort of abstract level what we mean by an autonomous AI agent economy. And I don't want you to take this as a canonical definition. It's just a definition. I'm probably going to have a new definition tomorrow. It's just one way to describe it. So there's different types of agents, autonomous agents. That's one requirement for a multi-agent system. And it tends to be the case that these agents specialize for pretty much the same reason we also specialize, right? There's this whole economic arguments behind why it makes sense for humans to specialize, and they equally apply to software agents. There's no difference there from an incentives point of view. And we tend to have many, many instances of these different types of agents. So let's say your specific use case has maybe 3 or 4 or 5 types of agents. Maybe your workplace has like 10 different types of agents. Then you still have like multiple software developers and multiple people working in product and so on. Each agent needs each other to get stuff done. So coming back again, workplace analogy, you are not going to achieve your outcomes there unless you work together. Otherwise, they shouldn't have employed you in the first place, or you shouldn't be there in the first place. And then in order to get stuff done, like humans, we need autonomous agents to communicate, which tends to happen off-chain, although occasionally can happen on-chain via smart contracts, and trade, which or contract and all the other cool things we can do on-chain, which tends to happen on-chain, but occasionally can also happen off-chain. So let's look at an example. OLAS Predict is a use case that involves a ton of people. Actually, some of them are just sitting here. Others are in the room and downstairs. It involves a ton of protocols. Basically, it involves 3 types of agents. So it's a multi-agent system with 3 types of autonomous agents: the market creator, the AMX, and the trading agents. And what they do as an emergent outcome is not anything any one of the specific agent does, it's what they do collectively. It is they are meant to basically create prediction markets which end users, that can again be autonomous agents or humans, can consume. So far this system has actually generated a ton of transactions, and so we can increasingly say a lot about the things that go well. We can improve the architectures, we can study the data, and we can actually use the data as well. So here's some highlights. So for instance, According to some benchmarks, they're not perfect benchmarks. These prediction tools have up to 75% accuracy. We've had over 89 participants in what's the staking test program called Coastal Staker Expedition. OLAS is launching this like native staking program to the protocol. It's actually going into the Code for Arena contest next week. So if you're like an auditor, please participate and maybe win some bounties. But basically, yeah, this is the precursor, and what it does is it incentivizes operators to operate agents in this use case. But these operators, as we'll find out in a moment, and these agents are rewarded in a very specific way. It's not your vanilla, set and forget, and I'll just get some sort of emissions. And the other interesting thing is that there's been a lot of code contributions. So not just a lot of operators, there's also a lot of builders. So some of them, again, sitting here. And Napta, Polywrap, other individuals, Gnosis team, have contributed code here. Now, I mentioned before, it generates a ton of data, and that's actually increasingly interesting, because if you think about any given use case that involves multiple agents, again, going back to the analogy of your business, you tend to get better by time through iteration, by updating your tools, your means of doing things. And what you ultimately want is that the data you're collecting directly improves like your processes, right? You want like this flywheel to be as uninterrupted as possible. And so the ideal flywheel is outlined here. So you have some sort of agent architecture you start with, which utilizes some sort of AI model or multiple of them. In the case of this use case, is the trader agent using these prediction tools. Prediction tools you can think of, for those who know what it is, like sort of AI workflows. And then you have that working. Now you can give very measured rewards towards agents hitting KPIs. What do I mean by this? Well, in a very sort of traditional labor context, you often literally get paid for the exact labor you do, right? If it's measurable, you work 3 hours, you get paid for 3 hours. You slack for 2 hours, you ain't gonna get paid. That's exactly what happens here. So in OLAS staking, the staking model, the smart contract, defines KPIs, and then these agents have to work into these KPIs. When they hit them, they get basically rewarded. If they don't hit them, they have lost their the opportunity to earn these rewards. And if they slack for too long, they're going to be evicted from the system, right? And so you have a emissions model whereby agents are only rewarded when they're actually doing useful things. The nice thing is that these useful outcomes for end users then arise, right? So in this case, the prediction market. But we also get the side product, which is basically we generate a whole bunch of synthetic data from these agents interacting. So in this case, we get all these prompt prediction pairs and a whole bunch of other data that can be useful in going and training a better AI model, right? And that's exciting because one of the big problems with decentralized AI is training, and I'm not going to speak to this. The other is data, because if you ultimately want to have a good model, you need very good data. And how do you get that? Well, you need use cases that just generate a shit ton. And I'm not saying like 100,000 data point or 1 million or even 1 billion. You need a lot of data. And so this means the more agents we can have which generate this as a byproduct, the better we can make our models. And so it's feasible then that we can take that data back to create some better models and then also some better architectures. So this flywheel is still like sort of cranking, right? It's not like spinning. But it's very exciting for us to basically iterate on that. It's where we spend a lot of time. Now, to the abstract. We had the specific use case, and so now the question is, how can you bring this OLAS protocol to a use case you care about and benefit from it? So the path this looks like is pretty straightforward. So you're, let's say, a protocol team. You define your goals. So you could imagine a situation where you're like some sort of DeFi protocol which cares about certain like actions to be taken or certain like liquidations to happen, things like that. You can define these as KPIs on that staking contract, and then develop yourself or with members from the OLAS DAO the agents which basically work against these KPIs. Then you deploy that staking contract, and you can then literally guide emissions to it by being a OLAS DAO member. So basically, members in OLAS DAO can guide these emissions. We'll see this in a moment. And then what should happen is that if you've built your agents correctly, and if you've defined your staking contracts correctly, which is obviously not a small if, but that's the heavy lift here, then from then point onward, it's like a bit like a machine, right? You dial it up and you kind of increase the number of staking slots, you increase, like you configure the system, and it just grows. And like, I'm not just saying this as some sort of theoretical thought exercise. That is literally what's happening with OLAS Predict. So we're in the third iteration of the staking contracts. The first one was Everest, then we had Alpine, now we have Coastal. They increasingly got simpler, and now it's a walk on the beach. And basically, at each iteration, we obviously got more data and were able to improve participation. From a token point of view, the way this looks like is that for those of you who know this model of Curve and the Gauge, it's a bit like this. So you have basically, for a long time in OLAS, governance is based around vote escrow. So basically, those who govern need to commit to the protocol for some time. So they need to lock the OLAS into VOLAS, and that gives them voting power. And for up to this point of OLAS staking coming live, this voting power can be used for things around developer rewards, for things around upgrading the protocol, and so on. But with this upgrade, what will happen is that basically members of the DAO can say, okay, well, this entity over here permissionlessly deployed the staking economy, and we care about that staking economy, or quite literally, the members who deployed that staking economy get some OLAS and care therefore about it, and direct emission. So there's a competition for emissions, and the mechanism is actually quite involved. Come to the contest, the Code for Arena contest. Basically, we don't just blindly emit. I already mentioned this proof of active agent mechanism where you basically have agents being paid by their KPIs. On top of that, we also have all sorts of mechanisms which modulate that any given staking economy doesn't get too much emissions and all these kind of things. Now, what this means is that as soon as the system goes live, anyone who is interested in such a staking economy to arrive at their chain basically can do that permissionlessly. And this model in detail is outlined here with all the participants. Now, where do we want to go with this? So one big challenge with crypto AI or decentralized AI is that the crypto people are now very excited about AI, and the AI people don't actually care. But that's, that's fine. It's not going to stay like this, because basically the value proposition is very, very clear. If I can own my entire autonomous AI agent, my AI models, if I can be sure that they are of the way I like them, whatever preference I have, that they are as transparent as they can be, that they are basically what I want, and no one can take it from me, that is a much, much stronger value proposition than one whereby I'm like on the behest of OpenAI or Claude or Anthropic in this case, or others, where at any day they can rug me in the sense that they can actually close my access, but they can even rug me in the subtle ways which they rug us every day, which is that the model constantly changes. If you ever run any benchmark against these models, it will go like this, right? It's not static, and that's an issue as well. So there's a lot of value propositions there, and we have to figure out how to tap into them and leverage them with our means, and then there's a lot of technical problems. But I'm not here to speak about the other technical problems. I want to provide you with a vision, and things I'm very excited about is basically creating more economies of agents. Because things we can then create is basically hospitals of agents. So in the beginning, this basically can be a means to research and complement existing kind of knowledge in the medical domain. You can imagine a Wall Street of agents, which in a way we have. DeFi already has quite a lot of autonomous AI agents, but I'm sure we can go further. You can imagine a Disney of agents, so someone who generates movies, and very high quality ones, where actually the capabilities are shared between these agents, and so you can prompt the videos you like without having to rely on some centralized provider to insert their advertising to show you all sorts of specific things, which is 100% what they will do, right? Centralized model providers. And then the Harvard of agents, you can have these researchers, as I mentioned, who complement your hospital of agents and so on. So ultimately, I think what we want is we want to create a lot of autonomous AI agents. I'm not so worried about the risks around this in the short term. We should worry about that in the long term. There was a great debate earlier. And we should very much think about how can we improve our health, how can we improve our wealth, and how can we improve our well-being by basically making it such that AI in the sense of models and AI in the sense of agents can be owned and accessed by all of us. So what I leave you with is basically a call to action to say, what autonomous AI agent economy will you create? And I really mean this, like go and sit down and write down a couple KPIs which you care about in the context of your protocol or chain, and then come to our stand, and then we'll have a conversation as to how you can make that happen. So that's what I leave you with, and then we have time for questions, and a thank you.
Thank you, David. Yeah, we have a few minutes for questions, just like 3 minutes. So, yeah, anyone have a question for David? Over here?
I think let's wait for otherwise no one.
Hi, thanks. Yeah, that was really interesting. I wanted to understand a bit better how you guys actually verify when a KPI has been fulfilled. There's like an Oracle problem there. Yeah, I don't think we went into that in the talk.
Yeah, great question. Basically, it's modular, so the architecture has certain it basically has a factory which is allowing you to create certain pre-existing modules, and then there's a way to add more. That's how it works on the smart contract level, and then conceptually, right now a lot of the metrics which we use are basically on-chain. So it's proxies often for the actual action someone might take, and for Ola's Predict that works just fine. I'm very excited, the Giza folks are around, other kind of ZK technologies are around, where you could imagine using elements of off-chain compute, verified off-chain compute, which you verify in that module to then unlock the staking reward. So it's totally open, basically.
Another question for David?
Over there.
Over here.
Hey, thank you for the presentation. My question is about, what is actually blockchain specific? I understand the presentation as you are basically just building agent systems which also happen to do transactions, right? Is there anything beyond that that makes these blockchain-based agents?
Yeah, great question. So there's a couple of things. So firstly, there's a protocol in the stack. The stack you can use in a way where it's basically just agents, like your Langchain agent or any other kind of agent. The one thing on the stack, which if you go for the sovereign agent type, is already on top of, is this sort of, it's crypto native in the sense that you can more easily send transactions. There's all sorts of things which are already there. You don't have to code. Then we have this concept of the decentralized agent. So that's still arguing at the stack level, where basically you can code an agent as a single node. You can then run it as a distributed system. Under the hood, it actually functions like a blockchain. So the agents individually write to the synchronized synchronized state machine and then shared state machine. And then they basically can use the staking machinery underneath as well. So you have a pretty robust way of running off-chain decentralized systems that are autonomous. Because one of the key things with smart contracts, obviously, is like they're autonomous in a certain sense, in the sense that no one can turn off the blockchain, but they're not autonomous in the sense that they actually can do anything out of their own accord. So in that sense, they're actually not autonomous at all, which these systems are. So this is the argument at the stack, and then we have the protocol as well. On the protocol, if you come from economics, there's a term of mechanism design. So you can basically design a mechanism for a game to be played on top of it. And if you design the mechanism well and the game is well described, you actually know what will happen. You know the equilibrium ahead of time. That's a bit what we're doing with the staking. Like we're basically defining like KPIs, and if they're well defined and if the agents on top are well defined, then you kind of coordinate them to do certain things. And that's basically one of crypto's big things, right? It's all about coordinating actors. So in a way, like OLAS is just this omni-chain protocol which coordinates all these autonomous AI agents and therefore very crypto native. So those are the two parts.
If we don't have any more, one more question here, I think that's, we'll conclude it after there.
Thanks for the talk. I want to ask about the capability of these agents to have also a knowledge base, or better say like a knowledge graph, so they can have better reasoning based on that, and if there is any privacy features that can also be with that data.
Yeah, so the stack in general doesn't have any opinion as to that topic. Like you could use an on-chain knowledge graph, you could use something like an on-chain knowledge base, you can use some database, you can use like something in memory, you can use a vector. So like it really depends on your use case. OLAS doesn't have any opinion about it. Having said that, like obviously there's certain like use cases currently implemented which have a certain shape. I think one thing people often like, specifically the developers who want to understand it all, kind of look at OLAS and then you see a certain thing and you're like, well, this is the kind of agent I can build, and that is actually not true. So there's the stack and the protocol does not care what stack you use. We've built the OLAS stack to make it easy for people to get started. If you have a better stack, come and run a staking economy on top of it, and you'll be happy.
I think we'll wrap it up there. David, thank you so much for your talk about
Thanks.
agent economies.